We are given the situation: a hot air balloon's height varies directly as the balloon's ascent time in minutes. Write a direct variation for the distance d ascended in time. So to solve this problem, we need to remember that we have the equation distance is equal to rate times time. In this case, we're going to be using the variable d for distance and t for time, and the diagram shows us what rate the balloon is rising. It is rising at a rate of 350 feet in 5 minutes. So we can go ahead and insert that rate in the place of rate in our equation here. We can rewrite it as d is equal to 350 over 5 times t. Now let's go and do the math. And 350 divided by 5 is 70. So we'll be left with the equation d is equal to 70t. And this here is a direct variation for the distance ascended in time t. Notice that it follows the same formula as a direct variation. Y is equal to k times x. Instead of y, we have the variable d, and instead of x, we have the variable t. So let's go ahead and put that down here as our answer. Part B asks us to graph the equation. So to graph this equation, we can go ahead and create a x and y coordinate plane. We remember that we know that in a direct variation, the line passes through 0, 0. Also remember that we know that when we have a direct variation, our k, our 70, is equal to the slope. M is equal to 70. And remember, when our slope is a constant value, not a fraction, we can put a 1 underneath it. So the slope of our direct variation is going to be 70 over 1. And now if we wanted to graph this, our x-axis is our time t, and our y-axis is our distance d. Now I'm going to label my x-axis as negative 1, and I'm also going to label my graph to be 70 here. And if I have the graph set up this way, then my first point will be at rise is 70 and my run is 1. So I'm rising up 70 units on the y-axis, or the d-axis, and then I'm running to the right 1 unit. So that's going to take me to here, and that is going to be the 2 points I'm going to use to draw my line. So now we've graphed the equation. Third question is, estimate how many minutes it would take to ascend 2,100 feet. Now 2,100 feet is the distance, and they're asking us how many minutes, what time it would take. So to solve part C, we would substitute in 2100 for D, and we would solve for T, solve for minutes. And so to do that, we divide both sides of the equal sign by 70. And on the left side, we'll be left with T is equal to 2100 divided by 70, and that's 30 minutes. So I'm going to put that up here. 30 minutes. Part D is asking, how many minutes would it take to ascend to 3,500 feet? Well, how would we do that? We would do the same thing, run through the same process as we did for C, except this time we're going to use 3,500 feet as our distance. Let's do that here. 3,500 in the place of D is equal to 7dt. We're solving for T, so we divide both sides of the equal sign by 70. And so T is going to equal to 3,500 divided by 70, and that's equal to 50 minutes. And I'll write 50 minutes as my answer.